Okay, guys, let's do the last check your understanding for Chapter 8. It's on page 524. Kitty's chewing my papers. Stop. Not Kitty. Okay. Administrators at your school want to estimate how much time students spend on homework on average during a typical week. They want to estimate mu at a 90% confidence level. So I've written down some key things, a 90% confidence level, with a margin of error of at most 30 minutes. A pilot study indicated the standard deviation of time spent on homework per week is about 154 minutes. So we'll mark that down as our standard deviations. So the question is, how many students need to be surveyed to meet the administrator's goal? Okay, so let's show our work. So remember, when we're doing a confidence interval for mean, we have our mean plus or minus our critical t times the standard deviation of our sample divided by the square root of our sample size. Okay, this part right here is the margin of error. That's what we don't want to exceed 30 minutes. Okay, now we don't have a mean, a sample mean, and we don't have a sample standard deviation. Okay, because we don't have a sample yet. We're looking for how big of a sample we need to get. So we don't have x bar or s of x. So we have to use, in this case, we have to use the standard deviation that's given. Okay, so we have to use our standard deviation that we were told. Okay, and again, we're only concentrating on the margin of error here. We don't need our point estimate. Now, we don't know what critical t to use either, because critical t is based on sample size. So if I don't know what the sample size is, I don't know what my degree of freedom is, I don't know how to find my critical t. So we have to revert back to critical z. Okay, so this is going to be the margin of error that this is going to be the formula for the margin of error we're going to use. And of course, we don't want this to exceed 30 minutes. Okay, so now we're simply going to fill in the critical z for a 90% confidence level and the standard deviation that we were given. Okay, so let's just do our aside here for 90% confidence level. The rest of this is 10, so this is 5%. Kitty, kitty, get. Stop. So our critical z, ow, she's biting me. Our critical z is going to be for 95%. So let's do that real quick in the calculator so we don't forget how to do it. I'll put it up here. Let's see, inverse norm, 0.95, right? So this is going to give us a critical z of 1.645, okay? So we will say 30 minutes is greater than or equal to 1.645, and only standard deviation that we're given is 154 minutes, and we're going to solve for our sample size. Okay, this one's a little easier to solve. All we have to do is flip those two, so we would get the square root of n is greater than or equal to this lovely equation. And then, of course, we've got to square both sides. So sample size, ultimately in my calculator, whole thing squared, and stick that in your calculator, and you would get something like 71.307. So of course, these are students, I believe, that we're surveying, so I can't do a portion of a student, and I'm always going to round up. So I'm going to say my sample has to be at a minimum of 72 students. Okay? So again, you have to use the only standard deviation that's given to you. Okay? So we don't have a sample standard deviation, so we're going to be given a speculative standard deviation, okay, or one that they have from preliminary research. And we don't have a critical t because critical t is based on sample size, so we have to revert to critical z. Okay, and we know how to use our calculator to find our critical z. Okay, that's it for solving for sample size. See you next time.